Hello, hello. Hey, Nui. Sorry for not removing the stream from the schedule, I think yesterday. Yeah, I really should be more on top of that. And then for anyone watching the VODs, the last time I streamed was what, Thursday of last week? Yeah, so I guess it's been 1 week. And on that day, it was two things. It was DP practice in the morning, dynamic programming, and then a mock interview in the afternoon. And both went so poorly that I I thought, okay, I'm just not going to stream for a while. So I had some time to sort of think about things, to do more practice. I was supposed to have a Google interview today, but as of like Monday and Tuesday, was just kind of very high anxiety and thought, nah, probably not ready. Especially Thursday went so poorly. So I think I'm feeling better now. I also think that my motivation is sharply declining. Hey, yo. Yeah. Uh, and that's part of the reason I'm streaming is because I can only do so many problems before I'm like, all right, I'm just doing the same problems over and over in Jupyter. So let's set the today command. I should already have it typed out. Yep, here's this. And then this is Thursday. This one's fine too. Yeah, sorry. Knew he's almost always first. So how far along in the search are you? August 6th. So I'm at the point of scheduling on-site interviews with the companies I was interested in: Microsoft, Amazon, and Google. Google is August 17th, Amazon is August 14th, and Microsoft is TBD. Phone call on August 7th too, which will probably help determine that. Yeah. Hey, Hamburger. Yeah, I appreciate the concern. I think there are a couple things happening here. One is, yeah, interview prep just kind of sucks. It just sucks. And two is that even if interview prep was going amazingly and that, let's say I had all my interviews already, the stream will probably dwindle sometime thereafter, probably shortly thereafter. Yeah, who's Smirk, Vinny? Yeah, long time no see. Is work-life balance a concern for you? Yeah, for sure. Yeah. I think that work-life balance matters to everybody, but that you just have a different definition of it most of the time. So that people who are working like 80-hour weeks probably couldn't work 100-hour weeks. But I think generally when people ask, they're mostly talking about the usual like 40-hour weeks or something. In which case, yes, that is a big concern for me. I think that all throughout Botland, all throughout Adam Learns. Oh, I forgot to run this. Oh man, that might change my microphone volume. Hopefully, I wasn't like blaring at people. Yeah, all throughout Botland and Adam Learns, it's not that I wasn't motivated, but it's that I have a limit and I can only do so much. So anyway, let's get to work. I think that's kind of it. What I've been doing, okay, good. Thank you, Nui. What I've been doing lately has been just going to LeetCode and sorting by just medium problems and just working my way down the list. And some of these what's going on? Oh, are we on? What is going on? Oh, I'm on page 2 somehow, but there's no indication that I'm on page 2. Huh. Okay. Well, anyway, this is where I left off. So what do we have here? Trying to find the last one I had done. Can't do those. Pancake sorting. Okay, let's do this one. Hey, throws. I should probably set up the. Well, I guess fine. Maybe we'll do this. Type problem for the current problem. I'll need to edit this one. Hey, Viper. Just slam that over there. And we do that. All right. So this got more downvotes than upvotes. I stopped caring about that. We're just looking at this anyway. And then some problems I will end up skipping because I think that they're just not worth it. There are some that I found where it's like, Alice and Bob are playing a game and here are all these complex rules and who's going to win the game. And it's like, This is just code the rules of the game more so than try to find an algorithm. And coding the rules of the game might take forever, so I just skip those. Hey Goose, yeah, I'm finally back. Okay, let's read. Given an array, we can perform a pancake flip. We choose some positive integer, k, up to the length of the array, then reverse the order of the first k elements. We want to perform 0 more pancake flips, doing them one after another in succession to sort the array A. Return the k values corresponding to the sequence of pancake flips. Any valid answer that sorts the array within 10 times a.length flips will be judged as correct. Okay, I think I understand this. So we are reversing the array up until k. Okay, so pancake flips. We're reversing the array up until k. So we want an array of k. Wait. K is what I choose, right? Yeah. So we want an array of k values to determine to get the array sorted. Okay, so let's look at some things here. So I guess we could always find the lowest value and reverse up until that. Is that actually possible? Is that what we're doing? So here it's at 4. No, we can't always do that. Because here it's at 2. And that means that we're flipping up until here, yeah. Okay. So what else could I look at here? So this doesn't work. That's good to write down. So some thoughts here are that maybe there's some sort of like BFS kind of solution. And we do end up reversing the same values multiple times. So we have 4 and 4 here. So it's not that we'll rule them out at some point. Okay. I guess I see what's happening. We can always think of what does the step before the solution look like. And we can see that it was 3, 2, 1, 4. And in order to even get to that, we needed 4, 1, 2, 3. Okay, so it'll always be sorted descending. Actually, I guess that's fine. It'll always be sorted descending up until the last element, which is sorted. So maybe we can use that information and we can basically try figuring out how do we. So every time we're going to be flipping from sorting descending to sorting ascending. So every step just before the last will swap between sorting ascending and sorting descending. I don't even think that's true. Oh, maybe it is. We had the final element and then everything sorted ascending. And then everything sorted descending and then the final element. I would have to think about this some more, I think. Because yeah, I think we can probably break this down. That's my biggest question right now. How do we break this problem down? So let's consider an array like, not 1, 2, 3, I guess, but like 1, 3, 2. So we swap it so it's 3, 1, 2. Will that even work? We want the 2 second. So I guess we swap the whole thing. So 2, 3, 1. And then swap the first 2 and then swap them all. So k of 0, 1, 2, I guess the length. So swap the whole thing, then swap just the first 2 elements, and then swap the whole thing again. We're reversing the first part of the array the whole time. So I guess if we can get if we can get the highest element to the right side of the array, then we can do the rest of the problem with just the first n minus 1 element. That's not the strategy that was done here. Yeah, let's see how that would work though. 3, 2, 4, 1. Let's say we did k equals 0, 1, 2, 3, 3. So now we end up with 4, 2, 3, 1. And then we swap the whole thing. K equals 4, 1, 3, 2, 4. And now we're left with two arrays. 1, 3, 2, and 4. And 4 is sorted. And sorting 1, 3, 2 should be pretty easy, right? We do the same strategy of try to get this to the end. So k equals 2 will lead to 3, 1, 2. K equals 3 will lead to 2, 1, 3. And now we have two arrays, 2, 1, and 3. How long is the array? It's up to 100? Because I don't know if this is gonna... They said anything... Any valid answer within 10 times a.length flips. So we have up to 40 flips here, and we have up to 1,000 the other way. I don't know for sure that this will be within 1,000, but then okay, then we say k equals 2, and we get 1, 2, and 3, and 4, and so we have our whole sorted array. So I think this strategy will work. At least it worked here, but the problem that I don't know is will it always work? And for things like this, I think the best way to solve it is to use a mathematical proof. And I'm not going to spend the time to do that for a practice problem. So, and then the other thing we can check too is, was this already sorted to begin with? Although we don't have to do that. All right, so then how do we write this? So our algorithm is going to be reverse the array until all of the largest elements, well, I guess it's like find the maximum value in the array, and then reverse the array until the maximum value is at the end, and then repeat with a slice of the array of size length minus 1. Okay, now finding the max is easy. This is an O of n operation. Reverse the array until the maximum value is at the end. So how do we do this? We pick that index. So find the index of the max and reverse to index plus 1. And that'll put it at the beginning, and then reverse to the slice length. By the way, I'm intentionally not reading chat today, or well, now, I guess. So we've started the problem. The problem command will tell you what it is. The today command will tell you what we're doing here. And all right, so reverse the slice length, and then repeat with a slice of the array of size length minus 1. When the slice size is 1, we're done. Well, really when it's less than or equal to 1. Okay, I think that's pretty good. I'm trying to follow, oh, did I delete it? No, here's the process. This is the process I'm trying to follow. Understand the problem, come up with the algorithm, weigh trade-offs, test the algorithm. So we tested the algorithm already, and now write pseudocode and test the pseudocode. Okay, so now let's write out the pseudocode. And for this, maybe it's not really worth it to do. Like I'm not too sure there's going to be an issue here. Yeah, is there anything I want to dive into more with this? This should be easy. Reverse till there, reverse to there. And we actually need to do the reversing here so that we end up with a new slice. Okay, no, let's just write out the code, I think. So pancake sorting, LeetCode pancake sorting. let's write out all of our stuff here. So we take an A, we call pancake sort. This returns an array. We print out A. We call test with all of our stuff. Is here. And output can technically be any number of things. So this is going to be a little bit weird to test. As long as it works, though, we'll try this. In fact, maybe even having tests is a bad idea because I don't want to spend a lot of time on them. So here's the algorithm I came up with. So at any given point, we want to find the max, reverse, and then keep repeating until our slice sizes. So we're just going to say return pancake sort implementation of A. Our slice is going to go up to A.length. And do we need any other state here? I don't know. We'll figure out if we need this state, actually. Whoops, what am I doing? Function. All right, we're going to take in an array. We're going to take in a slice size to find the maximum value. Max value equals max array. We can use Lodash, might as well. Reverse the array until the maximum value is at the end. So now we need, while true, if array index of max value, actually it's the last index of, A dot, is there a last index of? No, there isn't. Well, again, I'm pretty sure Lodash has that. And if it didn't have it, we could write one on our own. These things are very easy to write. We just start from the right and try to find this thing. So yeah, here's last index of. Iterates from right to left. Sounds great. Okay. So we do that. If last index of array max value is equal to, I guess we could just write this here. Well, it's not equal to the slice size. So now let's see if that's correct. The size starts at, let's say, 3. So we'll have 3 elements. So that means that this needs to be -1. So what we're going to do is we're going to oh, you know what? This doesn't need to be a while loop. Yeah, this doesn't need to be a while loop. Also, I realize we do need something else here. We need something like our answer sorted. So const answer equals this. Return answer. Okay, so if this is a case, if it's not at the max, then we're going to say answer.push last index of max. There we go. So answer.push that last index, and then answer.push the slice length. This actually should be +1 here, I'm pretty sure, because we reverse up until the next element. And then we have to do the reversing. That's the next thing I can't forget here. So we're pushing both of these, and then we're going to reverse up until that point. So reverse array up until last index of max, and then reverse up until slice size. Okay, so function reverse array, reverse end. So this is going to be a little bit strange. We're going to return. Oh, and we might need to actually say array equals this. All right, so we want to concat the first slice. So it's going to be 0 up until reverse end, exclusive, so that's good. And then second slice is going to be to slice the array from reverse end up until array.left. And we're going to concatenate the reversed first slice and the second slice. Okay, good. So now let's read this again. So we reverse both of these, then repeat with a slice of the array of size length -1. So return pancake sort interval array slice size -1 answer. Cool. Then we have our base case up here. If slice size is less than or equal to 1, then return. And that should be it. So let's try that out. So like I said, the answer that I get might be different from the one that they showed, but it might still be fine because there's lots of ways you can do this. So let's test it out and see if it's fine. So we have 3, 2, 4, 1, and we're starting with k equals 3. So that's going to be 4, 2, 3, 1. Then we have k equals 4, so it's going to be 1, 3, 2, 4. Then we have k equals 2, so it's going to be 3, 1, 2, 4. I don't think this is right. No. Yeah, I don't think that's right. Because at the end of this thing should be sorted, right? In fact, we should be modifying the array. So if we string it by 8 here, it should give us that as our answer. 3, 2, 1, 3, 4. That's not even correct. No, it didn't get modified. What did I do wrong? I guess because we're setting it here. But it's at this point, I guess, that we should have this. Yeah, so it is getting modified, but we have 3, 4, 1, 2. That's not what I ended up with here. All right. At no point actually did this get to the end, so I must have, maybe I did an off by 1 error here. Let's just take a look at this again. Let's start with our input that we had. So we had 3, 2, 4, 1. We find the maximum value, so it's 4. We find the last index of max, so it's going to be 0, 1, 2. So max value is 4. Last index of max equals 2. If it's not equal to the slice size minus 1, so it's going to be the length is 4. And it's not equal to 3. So yeah. So then we push last index of max. So we're going to push 3. Answer equals 3. And then we push the slice size 4. So what that should do, and what I guess it didn't do, is it should have moved the 4 to the beginning and then moved it all the way to the end of the array. And then I call reverse up until those, oh, whoops, this is supposed to be a +1. Okay, let's see if that worked better. Okay, no, something had to be wrong there. Let's keep looking at this for a sec. So we call reverse up to 3. So, and let's make sure I did this correctly. So L.slice, so we have an array 3, 2, 4, 1, and we want to go from 0 up until reverse n 3. Oops, put an underscore. So that's 3, 2, 4. That's good, yeah. And then we slice from 3 up until 4. Yeah, that's good too. Okay, then we reverse it, so it's going to be 4, 2, 3. That is fine, and we concatenate it with the other one. Yeah, that's fine. So now we're going to end up with 4, 2, 3, 1, and then 1, 3, 2, 4. And then we're going to reverse this whole thing up until the length. I typed that wrong, but yeah. And then we call sort on the slice size minus 1. Yeah, I don't actually know what I did wrong here. So how about we, yeah, I don't know what I did wrong. What I'm thinking of doing is debugging this, but I want to come to these conclusions without a debugger. And for all I know, I made some like tiny mistake here, and for all I know, it was some much larger mistake. Hang on one second. Okay. It's raining for the first time in forever, so I thought, oh, it'll be cool inside today. But no, it's still blazing hot in this room. Yeah, maybe. Let me run through this one more time. I had already tested the algorithm, so I'm pretty sure. Let's figure out what I should have gotten from this. 1, 2, 3. So k equals 3 would lead to 4, 2, 3, 1. And then k equals 4 leads to 1, 3, 2, 4. And then we go to slice size minus 1. Oh, right. I know what we're doing here. That's wrong. Okay, the max value needs to be, we need to start at a value. Yeah, there's from index. It's array length minus 1. So it should be slice size minus 1. Yeah, whoops. because we don't want to. We're always, the max value is always going to be at the very end, and even this is wrong. We want the maximum of the slice of the array going from 0 to slice size. And I think I had that written down, didn't I? Yeah, find the max within the current slice. I just ignored that. Whoops. Okay, so this worked now. 3, 4, 2, 3, 1, 2. That might be fine. So 3, 4 is definitely correct. Now we had 2. So k equals 2 leads to 3, 1, 2, 4. K equals 3 leads to 2, 1, 3, 4. Okay, we got those sorted now. And then we do 1 and 2. Isn't a reverse of 1 unnecessary? I think it is. Yeah. I think if 1 showed up there, then we can just delete it. If last index of max equals 0, well, if it's not equal to 0, then we can do this. Yeah. That'll remove one of these from here, and then I think that's correct. So now let's submit this. Oh, I forgot my reverse array function. Whoops. That's just a copy paste error. Okay, yeah, that works. Yeah, so that's good. I'll read chat and then we'll look through the solution. Okie dokie. Hey, Artemir. Oh no, pancakes. Too bad. And hey, Fled. And Thomas. Can't you create an empty array and do a select sort kind of algorithm? Maybe. I'm not sure. I'll need to think about that. It's always tough for me to go from the solution to reading chat to the like a better solution. So I'll look at the solution that they had in a bit. Calculate the inverse position and insert each item into a new array using the position as the key of the new array. Yeah. What happened to the sub button? I got rid of it like last week? I don't know. There's the no subs command. Let me just read that. What does it say? July 24th. Okay, so I guess it was a couple weeks ago. Yeah. So there should be very few subscribers in chat because there can be no new ones. So it's all the people who subscribed almost exactly 2 weeks before, or up to 2 weeks before I disabled it. Hey, Mar. Got one that used hash map. Second one that used a minimum heap. Did the 2 questions you mean for an interview? Hey, Vatzel. And thanks, Kyle. Where am I based? I'm in Washington State. And I actually did not have any interviews so far, Kennedy. When is the interview? Yeah, check the job hunt command. Or the today command. I guess I had one. No, actually, the today command won't tell you. I'll have to. Oh, it will. Also, wait, the today command never got updated. That's weird. Sorry, guys. I don't know what happened. I definitely. Oh, the bot wasn't running. Oh, darn it. Oh man. All right. Hopefully, yeah. Let me fix that. I typed it at the beginning. Whoops. 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 Sorry, guys. Yeah. I don't know if the problem even made it in. So yeah. Sorry about that. Here's the job hunt command, and it's got the dates for the interviews that I have scheduled. So the first one is going to be in 8 days. Actually, I'm not positive that's going to be the case. I have a call tomorrow with Microsoft. You don't know what Microsoft is doing, man. I talked to the hiring manager last week, and he's like, "All right, we'd love to get you interviewed next week." And now I somehow have a call with a recruiter. I was never in touch with a recruiter though, and the recruiter wants to ask me the same kinds of questions that the guy asked me last week. So I don't get it. I don't really care either because it's not like I have a scheduling problem. In fact, actually doing it this week probably would have been tough as far as getting offers goes. I can use LeetCode CLI. Yeah, I ended up just writing my own thing. That's probably fine. Although I think they also have a way of you submitting answers through there, which, yeah. All right, let's look at the solution that they have. Sort like bubble sort. However awkward it might be, it's the game that we play with in order to win the game. What a weird, stupid thing to include in your solution. We cannot move one tile without moving other tiles. As a reminder, the only operation we can perform, pancake flip. So starting from the largest value, 4, desired position will be in the tail of the list. While on the input, it's located at third. We look at the list from left to right. In order to move to the fourth, we do 2 steps. All right, so this is what I came up with. Yeah, this is probably not great. Is there a better solution that they have here? Well, they didn't list one. Let's look at this. Find the index I, reverse I plus 1, reverse X numbers. Yeah, so this is exactly what I did too. All right, great. Well, then we came up with a good solution. Oh, nice, Ian. Good luck. Sounds like an HR process thing. I see. Yeah. How to get my first Fang job? I don't know if you consider Microsoft to be a Fang company. If you do, then how I got it was just interviewing. But if you don't, then I haven't had a Fang job. Hey, Belted, this. Is Anki being of any help? I still haven't opened it. Yeah, I was saying earlier today that I think the problem that I'm having now is a motivation problem, and that's something that the stream has helped with quite a lot, which is like I'm streaming, so I might as well be doing this work. But yesterday, for example, I kept opening LeetCode at just random parts of the day, and I do like 1 to 2 problems, and I'd just be done. And then I'd open it again later and do another 1 to 2 problems. So right now we're at 145 problems solved. It's not a lot. I mean, I'm not even at 10%. Oh well. What are you gonna do, I guess? So what is that one we just did? Pancake something, right? Yeah, here. So next is complex number multiplication. I think we skipped this one before because I don't think I want to do this. This was the, yeah, I don't think this was interesting. Find all duplicates in an array. Now let's try this one. Yep, sounds good to me. Given an array of ints where 1 is less than or equal to a of I is less than or equal to n. All right, so then the only numbers in the array can be up to the length of the array. Some elements appear twice and others appear once. Find all elements that appear twice. Okay, so here we have, yeah, 2 and 3 appear twice. So could you do it without extra space and in O of n time? All right, so the question seems pretty straightforward. Remember, step 1 of every single interview you ever do is make sure you understand what's even being asked of you. Otherwise, you can't really answer it. So that's what I always try to start with. And I think it's pretty obvious. It says, get this, find the duplicates, and return them. And so the only question I might have in an interview is, if you had an array like this, do you return just 1 3 or do you return all of the 3s? It doesn't really matter. The interviewer would answer and you just do whatever they said. But yeah, this is the important part of this. And by the way, the wording makes it seem like, oh, never mind. They only appear twice, so that you couldn't even have that as a case. So let's think of just a naive approach for finding duplicates. We could say to keep a hash map of frequencies, and when we find a frequency of 2, to add it to the answer. This will not be doable because they say do it without extra space. And when they say no extra space, they typically just mean constant space. So like you can make a variable if you want, but you can't make a hash map. And an O of n runtime. So they're saying like 1 pass over the array and no extra space. By the way, whenever we have a hash map of frequencies, the other thing we could have done here is just kept track of an array of booleans, because we only really care if we found it before or not. Or an array of, anyway, it doesn't matter, an array of counts or something like that, which would just be frequencies. So how do we do this without any extra space? And 1 pass over the array. So this means no sorting, because we wouldn't be able to sort in 1 pass. This is always some like, can you see the trick kind of answer. How would we do this? We know, well, let's look at the numbers themselves. So we know that we have from 1 to n. And that numbers can appear 0 times, 0, 1, or 2 times. I'll say like 0 times, once, or 2 times. So there's a question that gets asked where it's like, hey, we have all of the numbers in an array up to the length except for one of them. So like we cut this out. And then how do you figure out the missing number? And so it's, well, sum up what you should have had. Like this one gets turned into a 0, let's say. Sum up what you should have had. So our target should have been 15. And our actual value is 12. And so you know that you're missing the 3 from here. I don't think you can do something like this here because you don't know which value you might have skipped, but maybe that's possible. So here we have, what's the sum of this? 7, 8, 2, 3, 1. It's 30. And what's the length for 8? Numbers from 1 to 8. And so if we had every number once, we'd have 8 times 9 divided by 2. So 36. Okay, so our difference from our target is from sum is 6. And then could we divide? Maybe we could say like what factors make 6. No, I don't think that works. I wanted to figure out if there's a way to figure out that there's 2 and 3. Maybe it works. I don't know. Maybe I should just try with another example. Let's say instead of 3, we duplicated 4. Then or wait, no, not actual sum. This is like sum from 1 to 8. By the way, did I even do that correctly? Yeah, I did. So the actual sum here would be 1 higher than we just said it was. So the difference will only be 5. Yeah, I don't know how this helps us. I mean, like, maybe it does. But what's the highest array we could have here? Yeah, it's this. And what does it actually equal? Reduce 52. And there should only be one way to form 52. But there are all these intermediate sums where maybe you can't know whether you can't know what the breakdown is. If there are 2 ways to form the missing numbers, then this wouldn't help. You could have any number of duplicates as well. The problem is if we know we can only do this in one pass and not use any extra space, then I feel like it has to be some sort of like, there's either some trick I'm not considering or there's a more math-focused way of doing things. And I haven't considered this enough to know whether it's going to work or not. I guess I need to list out even more examples. So let's do this. Let's just look at simpler ones. So 1 plus 2 plus 3 plus 4 should be 10. And we have how many different cases here? This is 7. We could double the 2, in which case it's 8. We could double the 3, in which case it's 9. We can double the 1s and the 2s, in which case it's 6. Could double the 2s and the 3s. And I think we're going to get the same answer we had here before. At some point, we got 10 for this. Yeah, so then this definitely won't work. Because we couldn't tell the difference between 1, 2, 3, 4 and 2, 2, 3, 3. Yeah, okay. So I'm glad I came up with a contradictory result for this because otherwise I might have still tried to pursue this. So that won't work. But is there something else we can do? Maybe if we knew, yeah, I was gonna say if we knew the length of the array was small enough, we could try to use a bit mask, but that's actually probably cheating because they say don't use extra space. Man, how do you do this then? And oh, so you can do. Oh, I guess they didn't say one pass. Yeah, there could be multiple passes, but you just they probably wouldn't help you because you can't store anything. So no extra space. What else can we do? We know that summing this isn't going to help. Is there some other mathematical operation we could maybe perform that would let us figure this out? I don't know. I really don't know. Yeah, I don't know how to satisfy this part. Okay, there's at this point I feel like we're dealing with a puzzle more so than an algorithm or data structure thing. Like I said, the naive approach would just be have a hash map, but we can't use extra space. So what else am I missing here? Okay, I wonder. All right, I said maybe there was some other math operation. I feel like there has to be. So maybe it's not sum. Maybe it's some like exponentiation, which I don't think it could really be that either, because we need something that doesn't have duplicates. And summing things led to duplicates, but maybe like XORing or something. I don't know. 1, 2, 3, 4 is 4. 2, 2, 3, 3 is anything XORed with itself is 0, right? So this is 0 XORed with 0. No, that won't tell us anything then. Yeah, never mind. Can't be this. Can't differentiate between 1, 1, 2, 2 and 2, 2, 3, 3. Okay, so it's not that. Yeah, maybe it is the product. So 1 times 2 times 3 times 4. I mean, even if it is, I I don't think this problem is worth doing anymore. Yeah, I don't think it's really worth doing. But I'm not even sure. No, this won't work either because you have 1, 1, 3, 4 also leads to 12. Yeah. All right. Can't be this either. Yeah, I don't have any ideas then. Well, let's code up the dumb solution. So frequency is this for I equals 0, I is less than length, plus I. Freq num equals default to freq num 0 plus 1. There we go. All right, so there's our answer that does not fit the constraints of the problem. And that's a waste of time. So I don't know how you're supposed to do this. I'm going to look at the answer. Yeah, how were you supposed to do this? Idea is you do a linear pass using the input array itself as a hash to store which numbers have been seen before. Okay, I did not think of using the original array. All right, yeah, we had extra space essentially. If we yeah, oh, that hadn't occurred to me. All right, well, whatever. Doing company specific problems. Yeah, I think what helps me is just streaming them. I think that's generally good for me. Oh, gonna mute, so no spoilers. Got it. Yeah, yeah, yeah. If you move numbers around, yeah, I hadn't thought about that for using the original array. Too bad. Think you can use the numbers as indices? Yeah. Yeah, I think they almost always mean extra space because even in this solution, it's like we defined a variable x. No, too bad. Now you can't do it. It's like yeah, I think they always mean no. Just use constant space. I had a break, yeah. Well, I had a break from streaming. I was still doing interview prep. Although, granted, that it was a very little bit on the weekend, and then I started doing it again more seriously on Monday. If you transform numbers in base 2, would it not be easier? So all of the things that I was suggesting here anyway, with adding or a product or exponentiation, let's say you did 2 to the n, all of those would only work assuming you don't have any overflows. And you're not allowed to use extra space. So whatever is passed in, like let's say a number is passed in 1, you can't turn that into a big integer or something like that. So you'll eventually hit a number, I mean, pretty rapidly too. Typically, like 64 is going to be the highest in most languages, where 2 to the x is going to be out of bounds and you can't add it or do any other math on it. So converting to base 2, I don't think would really help either. Then again, we know now the solution had to be use the original array for your storage. Also, just to be clear, I'm not reading chat during the problem solving. Thanks, CEO. Thank you. Yeah, shout out to CEO because CEO helped me over the weekend with dynamic programming stuff. I think since then I've basically given up on dynamic programming, which I think sounds kind of bad. But pretty much, if it comes up in an interview, I'll probably be like, "Look, I'll try to go through the steps, but this has never worked for me before, so I'll probably get the wrong answer." But at least I can go through the process. But I felt like I'd already spent like 8+ hours on it, so it's probably not worth spending more time. Can be extra space depending on the reviewer or in the interviewer. Yeah, it could be. And look, to be honest, I think this kind of question is a little bit tricky because when I hear extra space, what my mind translates that to is I can't store anything anywhere. And that wasn't really true. They were the key word here was extra. You have space, you just have to use it from what the problem gives you. How do you stay focused for so long? I mean, I don't. Streaming is what helps a lot. So yesterday, for example, I did I don't know, only a couple hours or 3 hours or something of problems. When's the interview? Check the today command. Happy to go over it with other mental model I was talking about. So CEO, like I said, I don't know if it's even worthwhile at this point. I think it's probably better for me to get help with all the other stuff, like what we're doing on LeetCode now, rather than try to fix that weakness. Because let's say it took me another 10 hours to understand, like that's 10 hours I could be doing other problems. What did they mean by extra space? They meant you can't do what I wrote here. So I made a hash map here. This is not going to work because it's extra space based on the size of the input. When am I having the interview? Yeah, definitely check out the today command. Sorry, I should probably make that clearer. Okay, yeah, I'll keep that on. Well, I'm not reading chat right now, but I will be not reading chat in a second. Okay, so let's move on. So lowest common ancestor of deepest leaves. I think we might have tried this one. Did I try this one? Lowest? No, I don't think so. Given a rooted binary tree, return the lowest common ancestor of its deepest leaves. Okay, yeah, let's try this one. Okay, there we go. All right, given a rooted binary tree. I don't know what rooted means in this case. Oh, let's look that up. This is something I would just ask the interviewer. Is a connected acyclic graph with a special node that's called the root. What? What binary tree is not rooted? Why would they say that? Huh. I mean, I don't think it's going to matter for the sake of this problem, but it's just strange. It'd be like saying, given a binary tree where each node can only have up to 2 paths, be like, that's the binary tree part of things, right? Isn't rooted just saying it's not a graph? All right, recall the node is a leaf if and only if it has no children. The depth is 0 with the root. Okay. Lowest common ancestor of a set S is the node A with the largest depth. Oh, lowest, not even least. Okay, got it. Largest depth such that every node in S is in the subtree with root A. Makes sense. Okay, so let's draw out some examples here. So we have something like this. I just need one more level, so we just got to write out up to 7 here. So the answer is 1 because the deepest level is here, and the common ancestor of that is the grandparent. So it's possible that we had this whole thing duplicated. I'm not going to draw new numbers here, and that there was some node at the top here, loop, in which case the answer would be 0 because our deepest nodes are here. So let's think of some other just quick examples here. 0, 1, 2, 3. The answer should be 2. So what I'm thinking of for the approach for this is find the deepest nodes, or find highest depth maybe, and then what I'm wondering is, can we always know that it's going to be like, this is what, depth of 3? Can we always know that the parent is going to be 2 to the 3rd higher in the tree? I guess that doesn't really make any sense, especially because in this case we only have 4 nodes. Okay, well, whenever I come to binary tree problems, I always think, let's just simplify it to something a little bit easier here. So let's consider some easier trees. Let's say we just had 1, so there's nothing. The answer is 1. Let's say we have 1, 2, 3. The answer is 1. And the only time we get to something a little bit different. Hikari, thanks for the raid. Welcome in, everybody. I am currently not reading chat, actually, so please do type the today command. But hope your stream went well. Hope you guys had fun. And welcome to my stream where we're doing interview prep forever. Forever and ever and ever. Type the today command to find out more. All right, and so here the answer is 2. So how do we get this? So I think the only way to do this, though, is to know what is the highest depth. And then maybe if we assign a depth to every node, or maybe we store nodes by their depth. And if we get that the deepest node is depth 3, no, that won't work, because in this case we have, okay, sorry. So I'm still struggling through this problem. Deepest node here is depth 3, but our answer is going to be 2 because there's nothing over here that's also of depth 3. Because if there were, then we'd have an issue there. So what if we get all deepest nodes and traverse up the tree until we find a common ancestor? All right, this'll probably work. Yeah, this took me quite some time to get to, I feel. So here we have the deepest nodes are 2 and 3. And since we know they're the same depth, we know we'll have to keep going up the tree. Yeah, I think this will work. This will work just fine. Okay, so that's our algorithm right here. Now, how do we write this as code? Well, we need to mark every node with its depth and its parent, and collect all of the deepest nodes from that, and then traverse upward from each until the nodes match. Okay, so mark every node with its depth and parent is O of n. We need to go through every single node for that. Then collect all of the deepest nodes from that list. So we could maybe collect the deepest ones as we go through this. It depends on if we want to use more space or more time. If we want to use more space, we could just keep a hash map. Yeah, I'll probably just use a hash map. Hash map to optimize for speed. So we're going to use more space here. We're going to use O of n space. And we could actually, there's something kind of interesting you can do here. So let's say we have our map by depth. As soon as you find something deeper, you can delete all of the older depths. But that's not really, we don't need to do that. But we could. So keys will be depth and values will be nodes at that depth. And then traverse upward. So we need to, yeah, I'll just write out code for this, I think, at this point. All right, so here's the code. We are going to need this. And I'm going to want this. So we take a root, we take an LCA deepest leaves, and that's that. Now forming trees here is kind of annoying. Yeah, let's just draw out, this one, I guess. Yeah, okay. So root equals new tree node 1, root left, new tree node 2, root right is 3, test root with the expected output 1, which is, I guess, the root itself. Yeah. Okay, so what's our algorithm? Copy paste that over to here. All right, so mark every node with its depth and its parent. So we'll say like nodes by depth, and we'll say mark nodes root. Yep, so we take in a node and we take in the starting depth value, and we know that it's 0 by default. So if the node equals null, then just return. Otherwise, the node's depth is going to be the current depth, and the node's parent is going to be, yeah, we could just mark it here actually. Well, no, we'll pass it. Parent equals null. And then we mark the nodes of the left and the right. And so that's it. Oh, and then we were also supposed to keep track of our nodes by depth. That would be helpful too. I guess let's put this here. Depth equals default 2 this dot concat or dot, does pushing return? No, it doesn't. It doesn't return the array. This actually doesn't matter. Yeah, we could just do this then. Yeah, then we'll just do that push over here. Okay, that's it. So now we should have collected up all of our nodes by depth. So that was number 1. Now we're on step 3. So now we find the deepest depth. There's no guaranteed object order. So what we could do here is just max keys nodes by depth. If we wanted to not have to do that, we could just keep track of the deepest one that we found here. But anyway, this should work as well. Oh, except for no, it won't, because the keys are going to be strings. Now what happens when you do a max of a string? we can make this even more ridiculous and say k parse int k10. All right, let's just print that out for a sec. I want to make sure that's correct. It should say 1. Deepest depth, it says 0. Which leads me to believe that I messed this up. Let me make sure I even did this part correct. Nodes by depth is 0 here. This means I messed up the code. Oh, wait, because I'm not passing in the right thing. Yeah. Now what do we get here? Converting circular structures. What did I mess up? Equal to nodes by depth to this. Otherwise, there we go. The node itself shouldn't have anything set. Oh yeah, because of the parent that we have. Okay, let's just not set that for a sec. Yeah, there we go. Okay, great. Yeah. I'm just testing some really basic stuff here because this is not really how I do things, but it's how I'm doing things for the sake of this problem. So then once we have the deepest depth, we get nodes at depth equals nodes by depth at the deepest depth. And then we just iterate over all of them until we have the same ancestor. So we're going to say true. How am I going to do this? Let's say ancestors equals map. I actually want to check to see if, I guess if there's only one, we just return its parent, right? Otherwise, we know that they can't have the same ancestor. Yeah, so if nodes at depth dot length is 1, return nodes at depth 0 dot parent. But wait, what are we supposed to return? Just one thing, right? Yeah. Okay, otherwise we get all the ancestors. So go through every node at that depth and get n dot parent. And then here's something kind of interesting we can do. We can say if we make ancestors unique and the size of that is equal to 1, then we can return that ancestor. And that's it. That's our answer. And it works. So that's that. I only tested with one thing, so it's entirely possible this fails on other input, or that I missed an edge case. And what do we have here? So what does this look like? 1, 2, 3, 4. Okay, so let's make that map, or that tree, excuse me. So this would be root 2, and the left's left is 4. Now that one is supposed to be equal to 4. Oh, I just misunderstood the problem. Okay, the common ancestor of a node can be itself, apparently. Okay, that's a little bit weird, but that's fine. So just here, all we do is we just return that node, not its parent. Okay, in fact, if that's the only code change we're making, then I guess we just go delete parent function. Not sure why this is taking so long. These trees aren't very large, and what I'm doing is O of n. Time limit exceeded. Okay, then I will need to come up with a better way of doing this. There's one other thing that I think is weird here, though. Largest depth such that every node S is in the... This is not the right definition if they said to return what I returned there. But that's not the problem we're running into now anyway. So let's see. Is there a better way to have done this? We have to... Oh, it could be that this is timing out, not that my algorithm has a problem, just that this code has a problem. We're going through each node at the depth that we had and getting its parent. And we want to see if this is... So I guess if we had a lot of nodes at a particular depth, this is going to take a lot of time, especially doing unique. Could we... Well, I guess if we had a lot of nodes, we could know exactly how far up we have to go. No, we can't. Because this is not a complete tree. Hmm. What other improvement could I make on this? Because what I'm doing right now is we go through each node, we mark to find the depth. If we didn't do that, it's possible there was another node that was deeper. So we end up with all of these, and then we just advance up. Oh, wait. The ancestors could have been the unique of this to begin with, because each level is going to cut this down by 2. Yeah. So if the size of ancestors is equal to 1, okay, so then maybe what we should say here is ancestors. I do this. I guess we could just modify nodes at depth. Yeah. That'll only help out a tiny bit here. This isn't going to help out a lot. It's cutting out some operations, but it's not changing the time complexity. I kind of refuse to believe that that on its own. Nah, whatever. Okay, I'll reach out. Where did I? Yeah. I'm not gonna do prep even if I get a job. Someone in chat has been doing prep even though they got a job, and they said they're still doing a couple of hours of LeetCode every day. I think it's fine if you find it fun or if you think it's helping you somehow. But if you feel the need to do it still after getting a job and you don't find it fun, then there's probably an issue. Hey, Ori. We're having a hotkey daemon for Windows in order to fix the broken launch program using hotkey system. That's the general concept done. Oh, nice, Hikari. I had made something like this a while ago using auto hotkey. I wonder if I can show you guys. Anyway, what it did, I I pressed a hotkey and it would pop up a dialog, and the dialog would basically look like this. It would be like A would be like open paint, and B would be whatever, open calc.exe or something, and C would be like open Chrome. And so this dialog had a global hotkey to spawn it, and then it had hotkeys to spawn everything else that you might do. And D might be something like go to a website or something. So a lot of people use something like Launchy on Windows for that, but I know what you're suggesting. I think it's something different. I think it's the when you right click something here and you go to properties and set up a global shortcut that it doesn't do what you want it to do. Isn't this a too long solution? In board would be a mess. Well, first of all, everything that I'm doing now is going to be digital. So this is moderately long for a solution. Yeah. I'll look at the solutions that are there and see where I can improve this. And hi, everyone who's dropping in. Are they basically just handing you a heap? So you look at the last item in the list and divide by 2, then test out the chain. If the ancestor node is the rightmost, then continue up. Otherwise, the lowest, I think. Aren't they handing you a heap? I guess so. Yeah, I guess so. I guess if it's always going to be sorted like this, then it will always be the minimum values of the root. But I don't think that property of this helps exactly, because you could still have a very imbalanced heap that satisfies the minimum or maximum property. If you still find it fun, you should really find more challenging jobs. I don't think that's fair. I think you might find it fun. I mean, it's like you can kind of look at these as just solving puzzles, right? And you might like solving puzzles after you get done with your job. If it's unbalanced, it'll be leftmost, right? I don't think so, but I'm not totally sure. Anyway, let's look at the. Let me turn that off for a sec. Let's look at this. To recursive. short and simple recursion. All right, so what do we do? O of n, recursion management. Helper function, return the subtree height and LCA at the same time. Null node will return depth 0, leaves will return depth 1. All right, so what are we doing here? H1. It's H1. Turn 0, the depth, okay. So they're getting the depth and then the lowest common ancestor. Oh, that's clever. Okay. So I didn't need to, while I'm getting the depth, I could also keep track of what the ancestor would be for this. Yeah, that's clever. So what I was going through is I was marking each one, okay, this is 0, this is 1, this is 1, all of these are going to be 2. And we could have also said while we're doing that, like, this is 0, and by the way, for the next one, it's going to be it's it's going to be this. Okay, yeah, I see. So they say take this node and then everything after this is the next step. How's the job hunt going? It's going well. Yeah. I got more information in the job hunt command. So whenever it comes to problems like these, this is something I was. Can I give a quick overview of how I'm using LeetCode? Yeah, for right now, I'm just doing medium problems, any category, and just going down the list by acceptance. But how I originally had done it was by going through every single category one at a time and making sure that I knew each type of problem. There are some that I still don't feel like I know that well, but that I'm just kind of hoping don't show up in the interview at this point. I was going to say something about a realization I had. What was it? Oh, yeah. So, learning. So, this is something that I think was very interesting. I came to a realization myself, and this kind of made me feel a little bit better. And I wrote it as go easy on yourself. So, I'll try to sum this up. When you, let's say you've never done a LeetCode problem before, and you do one, and it's like, hey, sort the array. You might have never seen how to code a sorting algorithm. You might have done it before. You might have used a sort function, but you might never have coded it. So the first time you get a problem like this, you might not know about quicksort. You might not know about merge sort. You might not know about whatever, bubble sort, anything. And so you're kind of trying to come up with it. Cool. By the end of that, you can definitely say that you learned, like, well, now I know what sorting algorithms are. And maybe you haven't internalized them yet, but you can at least say that is a specific learning that I could take from this. At some point, you've gone through, okay, I know VFS, I know DFS, I even know like pathfinding stuff. I've used binary trees, I've used directed acyclic graphs, I've done whatever other number of things on this list. You eventually get to the point, and I feel like I'm at this point, where you solve a problem and you're like, I don't even know what I should have learned from that. Like, what could I even have done differently next time so that this didn't happen the same way it happened now? And at that point, I think what you're really learning is heuristics, and you're subconsciously training yourself to find patterns a little bit faster and a little bit better. But it's not something you could quantify exactly. You can say I did 5 problems, but you can't say something like I got 20% faster at solving this because you don't really know. Whereas you could, at the end of one of these questions at the beginning, say like, oh, I learned about DFS. Now I know how to implement it. I didn't know that before. So this happened to me enough where it's a problem like this. And I'm like, what could I learn from this? And I think there's still something, and I think it's really hard to figure out sometimes. So in this case, it was what I'm doing in 2 passes, maybe I could have done in 1 pass. And it's very general, right? Could possibly have been done in 1. This is so general that you almost forget it sometimes. There are other general solutions you kind of come to, like break the problem down and I don't know, consider simpler constraints and test it out and whatever, like see how a human would do it. These are all general things too, to the point where when you're stuck, you might not think, should I break the problem down? And I guess that's the train of thought you need to drill in while doing these. So I'm still going to try to learn from all of these that I'm doing. And I think it's challenging. Didn't I have an infinite loop? I might have. I'm trying to think. It's very likely that I did because you're right. It's it's unlikely that I shaved off a couple of milliseconds and that's what let me do this. Originally, I would have been getting. Yeah, I did have an infinite loop because I was never doing the ancestors of the ancestors. I was always doing the ancestors of the lowest level. So that's definitely correct. Yeah. 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 And just to be clear on what is BFS and DFS. So breadth first search is you take a node and then you examine each node in the order you find it so that you're going by breadth at any given level. So you're going to go like this through the tree and then down to here and then over to here and then down to here and then over to here. So you're like zigzagging through the tree essentially. Depth first is you're going all the way deepest as you can at first, and then the deepest over here that you can, and then the deepest over here and the deepest over here. So it's just different traversal orders, that's all. All right, so let's keep going. I'm just going to grind out these problems all day. Well, not all day. I'm probably going to stop a little bit around lunchtime, maybe go do them on my own afterward. All right, reduce array size to the half. I wonder if someone, a native English speaker, wrote this one. Given an array, you can choose a set of integers. Okay, so let's update this as the problem. And remove all the occurrences of these integers in the array. Return the minimum size of the set so that at least half of the integers of the array are removed. Okay, I'm not sure I understand this. You can choose a set of integers and remove all the occurrences of those integers. Return. Okay, I get it. Return the minimum size of the set so at least half the integers are removed. So choosing 3 and 7 will make the new array 55522, which has size 5. Possible sets of size 2 are 3, 5, 3, 2, 5, 2. Okay, yeah, that makes sense. Choosing 2, 7 is not possible since it'll only remove 3 elements. Okay, I think I understand the problem. So, and all we're trying to do is return the number of elements we have to do for this. So the very naive approach here would be, again, we could like count frequencies and then figure out, and then like keep taking the largest frequency until we're at a size of, I guess, less than or equal to half of the original size. And so, okay, counting frequencies would be O of n time, O of n space, and then keep taking the largest frequencies. We would have to sort the frequencies themselves, so O of n log n, and then go through probably only like 2 or 3, probably up to like half of the array space. But yeah, I guess that would be another like O of n operation. So overall, it'd be O of n log n time and O of n space. Is there a better way we could do this? What if we sort the original array? So then now all of the same element will be grouped up. 2, 2, 3, 3, 3, 3, 5, 5, 5, 7. Then what though? I guess in order to figure out a group size now, you'd have to do O of n. Yeah, I mean, I'm going to go with the frequencies way that we had done this. Is there anything else to really consider here? I don't think so. I think we just pretty much write the code for this now. All right, so const frequencies I equals 0, I is less than. You know what? Let me just do this as a for loop. I don't know why I don't do this. Frequency v equals frequency v plus 1. So now we have all the frequencies. Now I want to get like the sorted frequencies. And we want to get the values. We don't even need to know Yeah, we don't even know what the keys are. And you want to order this descending. And now we just keep taking frequency. Okay, this is impossible to write coded. Now we just keep taking frequencies until we hit the size that we need. So const target size equals. Now they did not say what to do when you're. Nope, the length is even, so never mind. We don't have to worry about that. So then we can always just say array.length divided by 2. And we just say while, and we say a current size. Cur size equals target size, or no, array.length. While cur size is greater than target size. Cur size minus equals sorted frequencies dot shift, and let count plus return count. There's our answer. I'm not sure if this part's going to work, in which case I might need to test this a little bit. It's also very likely from this. Yeah, there's probably an infinite loop in here. Let me look at this one more time. So we go through everything in the array, and we set the frequency correctly. Okay. Then we do order by all the values of frequencies. Yeah. And then I don't know if I did this correctly. Current size, target size. Yeah. Okay. Well, let's type this in then locally. That's what I think I messed up. Possible I did something else wrong. So write out our test here. Min array min set size. Every bar. I meant to type array, not what I just wrote. Now let's get this description. Where are our description? Here. So 2 we have for this stuff. This is 1. This is 1. I'm not going to write all these out because presumably it's failing on even the simple cases. No, it actually passed on all of those. Okay, fine. So there's some other test case where it's breaking, which I find surprising. Because if it works for one, I feel like it should work for all of them. Yeah, it works for all of those. Okay, so then there's something else that I'm doing wrong here. What is this input? And what is this supposed to be, I wonder? Oh my god, there's like a million of these things. Time limit exceeded, though. And it's the last test case, too. I can't even copy all of the output. Okay, so how would we fix this so that we don't run into that problem? It's a time limit problem. If I have the frequencies and I sort them, and I keep taking the top frequency, I guess it's shifting that's probably causing this. So if we sorted this ascending and we popped, that might actually help. Because then we're not shifting by, yeah, that one. Okay. Let's see what chat said. I don't think you need to sort, just pop the maximum out. And if your language has a way to pop an O(n) by swapping with the last element and trimming. Pop the maximum out. How would you get the maximum if you don't have it sorted? O(n) to get the maximum? Oh, I see what you're saying. Well, it's O(n) to get the maximum, and then O(n) again to shift the maximum out of the list. Why is taking the largest frequency n times log n? Sorting is what's n times log n. Sorry, that was what was implied here for me. So since we know we're going to be taking lots of these, we should sort it once so that we only have to, so that our maximum is always at a deterministic location in our array. Want to do a 5-minute coding challenge with me? I kind of want to stick to LeetCode for today. They're all kind of coding challenges, though. That for some time wasn't the previous code too long for an on-site interview? It might have been, yeah. And so then I looked at the solution, and we found that I could have used one pass to do what I was trying to do in two passes. You don't have to sort. You can do that in O of n-ish instead. Right, you don't have to sort. And so this is where I think it's tough to answer this stuff in a vacuum. We're told, hey, here's a problem, go solve the problem. And this problem has constraints that might not ever match what we have in a real world situation. In a real world situation, if we know that we're going to get tons and tons of numbers and that typically they're going to be very low frequencies for these, we'd probably want to sort once and then use those numbers. If we know they're just going to be, let's say, like 10, 20 numbers or something, then sorting might actually be overkill, and just iterating over to find the maximum each time could be fine. So that's where it would all depend. And I think just talking about that in an interview would be fine. Adam learns his build with React. Yeah. I'll see it when the live releases as a vid. Wait, what are we talking about? Oh. When this stream turns into a VOD. Got it. Yeah. Yeah, so let's look at the discussion for this one now. I think my way of doing it is not like terrible, but let's see. Someone did it in O event. Count the number of frequencies, create an array of lists with a frequency being the key, the numbers of that frequency in the list, count backwards, return once half size is reached. Yeah, so this is something that's kind of interesting here. If you ever know that your input size is up to a certain amount, you can always use arrays as your hash map, essentially. And then just iterate over all the arrays, which is another thing that my code has to do that this wouldn't have to do in order to even just get the values of a map that's an O of n operation. It's not like they're just there in constant time. Can I show the bottle link? Yeah, it's, as you might expect, just the bottle command. The problem is that I don't think it exists anymore. As in, like, I don't even think the people who made this bottle are making it, because it's made by some company called Cool Gear. And if you search for Cool Gear online, they have a website, but they stopped selling this. Hang on, let me see. Where? Oh, they have a 64-ounce one, I guess. But I think this one's 75 ounces. Yeah, I don't think it exists anymore. How much? Yeah. You're popping O of n times, but I'm popping from the end of the array, so that's going to be a constant time operation. Like the way that I end up doing it is sorting ascending, so that I can pop this off of the list, and it's not gonna resize the list, most likely. So shouldn't be too bad. What keyboard do I use? Check that out. Would a real world interview let you use Lodash? In a real world interview, and this is something that I don't know if you heard or saw the mock interview on Thursday, but CEO was talking to me about how if you have a function that is pretty obvious, like let's say find max element in array, you don't need to write that out, because chances are it's just so easy. You'd say like largest is 0 or negative infinity or something. You'd iterate over the array, iterate and compare with largest, and then return largest. It's like the amount of time it took me to do that to show the interviewer, oh, hey, I know how to write basic code, is not worth it. And you could just assume that this exists and just delete it all and say something like, oh, yeah, okay, so max equals the largest value in my array. And then here's what I would do something with max. So would you be able to use Lodash? You actually wouldn't even have to write the function at all, or even know that it's in Lodash. You could just pretty much make up that it exists and then use it. And no problem, Oreo. Yeah, I'm welcome. Popping in that case would be O of 1, as I said. And even if popping is O of n, it's going to be O of n times number of pops, which is probably much less than n. Yeah, I see what you're saying, Supercuber. But finding the max, like worst case scenario of finding the max n times would be O of n squared. Actually, it's yeah. Oh yeah, sorry. I should turn this off for a sec. Thanks, MLS. Anyway, okay, let's go back to not reading chat. I'm gonna do another problem. So we did this one. Next one is this, I guess. What's up with negative infinity and not the first element? You could use either one. Yeah, you could use null. You could use like have I found it as a boolean. You could My point was that it's pretty trivial to write the function, and the only thing you really do by writing it would be potentially get it wrong, and not really show, hey, I can write a for loop. All right, I think this is going to be a little bit tougher. Let's try this out. I'll go back to not reading chat. So return any binary tree that matches the given pre-order and post-order traversals. Values in the traversals pre and post are distinct positive integers. Duh. I never like these. Okay, so first what we need to do is we need to say what pre-order and post-order are. So pre-order traversal is the node, then the left, then the right, and post-order traversal is left and right, and then the node. So if we have a tree, like, I mean, I guess these work, but let's just draw out some more here. No, let's use this as an example. So let's say this is our tree. So our pre-order traversal, we list the node first, then the left, so then that node, then the left, 4, 5, 3, 6, 7. And the post is going to be, so this is NLR, this is LRN. So we're going to go all the way to here. Wait a second. So we're going to get 4, 5, 2, 6, 3, 7, 1. Is that even correct? Hey, they got the same tree that I have. Nice. So post order. That can't be right. No. Refuse to believe it. Post order traversal. Actually, do refuse to believe it. Post order is A, C, E, D, B. Yeah. I don't know what that other thing was. That seemed wrong. So I probably wrote this out correctly. Who knows? So how do you form a tree from those? Because that's what we're given is the pre and the post order, and we have to form the tree. I mean, we're gonna have to use this. Also, they're gonna be passed into us as nodes. No, they're gonna be passed in as numbers. Really? Oh yeah, that makes sense. Well, I guess it kind of makes sense. Okay, so at any given point, if we go through the pre-order traversal, we'll know what the current node is. And then the next ones in the list are going to be all the lefts and then all the rights. And then post-order traversal, we know that we have all the lefts first and then all the rights and the node at the end. Okay, I'm like kind of getting this, but it's going to take me some time. Pre, post. Yeah. So we know that the first node in pre will be the root of the tree. And then we know the next node Actually, we don't know anything about the next node at that point. Could be the left, it could be the right. Because we could get a pre-order of 1, 2 and a post-order of LRN. So 2, 1. We need to know that the tree that we form is this. Alternatively, if we get pre-order of the node, then this, and a post-order of... Oh, no, we can form multiple trees. Yeah, we can form multiple. Because I was going to say either one of these is fine. Or this. Yeah, you wouldn't be able to tell. Regardless, still actually doesn't help me that much. I still need to figure the rest of this out. So once we have this, then we would know, the first thing in here is the left. So I guess we have to advance pre-order until we hit that left node to know that it's there. And in this case, we had this graph. So start with a pointer. So pre-pointer is 0, post pointer is 0. Now, while pre-pointer is not equal to post pointer, then we have the root and all of its left children. So we start forming a tree like this. Then we get to a node that's the same, 4 and 4. So that's the final left child. And then we advance them both. Oh, I don't know. Yeah, I think it's something like this. But I don't know for sure. Because, okay, let's say I did get this 1, 2, 4. Then the 5 has to go here. And then we get to the 2 and we know that was, I don't know. Yeah, I don't know. I'd have to struggle through this. I think it's worth continuing to try to figure out what else I can learn about this, but I think it's very difficult for me to reason about this. How would we even construct, let's simplify the problem. How would we construct any binary tree from the pre-order traversal alone? Because maybe that'll make things a little bit easier. We know that it's NLR, so we know the root has to be 1. Then everything could be a right child, actually. So this pre-order traversal could result in like 1, 2, 3, oh, well, not like this, 4, 5, 3, 6, 7. And that would still be fine. Yeah. And likewise, it could go the opposite direction, and it could be this. So it tells us really very little. And I'm guessing it's the same for any of the traversals without knowing any other constraints. But we have 2 of them this time. So I guess as we're parsing through, as we parse through the pre-order traversal, we know that the first node is the root, then nodes that follow are either the left or right children, and we can't discern. Yeah. Yeah, that's why this is so tough for me. Because the only way we can figure anything out is by comparing values we've already seen in one with a value in the other one, and using that to try to figure out where this might have been. And I don't know how we're going to form this. And I don't know how much I want to try. I know that sounds silly, but I kind of want to look at the solution and then just move on to another problem. And then maybe come back to this one and see if I internalize the solution. Mm, is it worth figuring it out? No, I think I will look at the solution. Yeah. Let's see. Final binary tree is this, then the pre-order traversal is this, post-order traversal is that. If we know how many nodes the left branch had, we could partition these arrays as such and use recursion. Say the left branch has L nodes, we know the head node of that branch is pre-1, but it also occurs last in post-order. L equals post dot index of pre-1 plus 1. Now in our recursion set, the left branch is represented by. Okay. All right. Yeah, that's, I think, going to be tough. Let me turn this off for a sec. How can you study efficiently on LeetCode? The way I had done it is I went through all the categories to see where I needed more help to begin with, and then I kind of drilled just those problems. So if you go to problems and click tags, there's like 40 tags here. So I just went through all of these and tried to figure out where I need help. And then I went and watched a bunch of lectures through MIT and Harvard and YouTube, the accredited school of YouTube, and took a bunch of notes and then kept doing more problems. So I wrote out 1 billion notes at this point now, which you guys have access to with the notes command. And then you do mock interviews and stuff. Now, what happened with, there we go. I think it'd be 4, 5, 2, 6. Is that what I had? 7, 3, 1. No, it should always be left before right. Yeah, so I don't think you're correct on that. Oh, wait, no, hang on. Wait. I wrote 3, 7, 1. Yeah. I misread what your thing was. I think you are right. This is left or right? 6, 7, 3, 1. Yeah. You're right. You're right. Hey, UI. We do know the values are unique. Yeah. Yeah. Am I subscribing to LeetCode? No, I'm not. That's why I'm not doing any of the problems with a lock on them because I can't do them. I don't think LeetCode is worth subscribing to. But then again, I haven't subscribed, so who knows? But man, one thing I did try. Oh God, I hate LinkedIn. I just hate it so much. I think it's the worst. And I tried LinkedIn Premium because they had a free, like you could get it for a month. And I did absolutely nothing with it and then canceled it. They let you send 5 mails to people, but I asked some of my friends, like, hey, did this actually help if you did this? And they were like, they pretty much said yes at first, but then I said, well, did it lead to an interview? Did it lead to a job you got or liked or something? And they said no. So I thought, okay, this is just a waste. I don't know if people in chat have had a better experience with that. I'm sure you can get responses, but I don't know if that leads to anything better than if you just applied to the job. Yeah, that is what you wrote. Yep. Yeah, and I still actually I want to take some more time to understand this because I think I still don't get it and I want to get it. School of Twitch. Yeah, bitrate basically treats it as like random pixels on the screen. Having a LinkedIn profile is a good idea. Yeah, lots of jobs have had a section for what's your LinkedIn profile and mark it as required. and I just don't. I don't like it. What does it have that regular LinkedIn does not on getting a job? Some like silly things. I mean, you can go to the site and find out. It's something like they'll tell you stats on who applied to a job, what skills they have, excuse me, maybe where you rank in that. You can you can send messages to people who aren't in your network and something else. I don't know what. Did I have any interviews? You mean this time around? Or cool. I'm not sure if you'd asked the question before. So this time around, no, not yet. But check out the job hunt command. Yeah, shows who viewed your profile. Like this stuff, I don't ever want to go to LinkedIn again in my life, basically. So getting LinkedIn Premium was like a, well, if it helps with the job hunting, great. And then I canceled it after like a week. Okay, so yeah, that one wasn't very good. I am still not actually certain. Okay, okay, I think I understand how this works. I think. Did we know that this is we don't know this is balanced. First order left, post order right, and then the root node. Like this is just one such tree that we've said. We could have said that the entire thing is the left, and that the entire thing here is the left. Like, couldn't we always have just drawn this out as just like a line? Maybe not. No, I don't think we could have. Yeah. Murphy, thank you. You definitely don't have to though. I'm not looking for money doing this stream, which is why I turned off subs. A line is not a binary tree. You would either go left or right. I mean, a line is a binary tree. It's not a, what is it, complete binary tree, but it's a binary tree. But I think that you can't always make it a line. Yeah. Yeah, I guess that's the important part. You know where the sections start and end because you'll see the same section show up in both of these. Okay, so maybe it's worth writing that down. This is why I think it's probably better for me to study all of the LeetCode stuff leading up to the interviews than system design stuff. I'm hoping the system design stuff stays in my head, but I don't know how good that's gonna go. Oh, really, Poetry? Wow. Kind of surprised because yesterday I was curious and I searched on YouTube for something like interview process, and someone was using a site. I think it was like interviewing.io. I don't know what. And they got connected with an interviewer. And as I'm watching, I'm like, how in the world is this going to help me? Like, I don't know if someone else stumbling through problems is, or even solving problems, whether they do it really well or really poorly. I don't know if watching their thought process is going to help me unless that's my thought process. And really, when I go through these, this tells me kind of enough that I would have needed to know. So I'm glad. I'm not trying to say it shouldn't help you. I just I don't know how helpful it really is, or if it's just bringing attention to this. Well, thank you, Murphy. Yeah. Oh wow. Yeah. Awesome. 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 I think it's really good. I got to do a course on note taking and organization and everything. Prepping for a technical phone screen. I'll be spending a lot of time in LeetCode. Are there other streamers or audio video content you find helpful? There's a lot of stuff that I've found helpful. So I've got, like I said, I've got my notes. By the way, welcome, Scrabble, and good luck on your interviews. I've got some notes that I took, and they've got some resources in here. So in system design, for example, there are a lot of resources that I had. And then I also had a note on dynamic programming, which I think is okay. I don't think it's great, but there were some MIT lectures over here. There was, like I said, there was a Harvard lecture in the system design thing. I don't think that was even worth watching. But yeah, there are a lot of those sorts of resources. Any other particular YouTubers or streamers? I don't know. I'm sure there are some. And if that's up your alley, then yeah, I'd say you could probably ask around and chat or on Twitch. The link doesn't work for you. Can you try just notes.adamlearns.com? And am I a self-taught engineer? No, I'm not. Wouldn't be doing it in OneNote. Well, I think that sort of course, which I don't know if I'll ever make, would just be a general one. So this is kind of, I know that the title of this blog post is organizing your notes with OneNote, but there are a lot of general tips that I say are helpful for everybody. And like this, for example, do as much or as little as you can. It's obviously not technology specific. But yeah, I think a lot of people are like, well, if I take notes, I got to take notes on everything. And no, I don't really have to. It's a good way for me to start learning code. Check this out. And by the way, King, I've had this happen a bunch of times, so I'm going to try to preempt something that may not even be on your mind at all. But typically, I link this in because this is exactly my advice on coding. And then people ignore that blog post and then they ask me another question. Please don't ask me another question about learning coding until you read the blog post. Then feel free to ask whatever you want. I'm totally fine with that. It's just all of my advice is already consolidated into this post, so I'm not going to be able to answer any differently from what that already has in it. Still no, do I need to be on PC? No, you shouldn't have to be. Huh, that's strange. Yeah, it should work everywhere. I think I might have missed a message. Oh, yeah. Hey, Flex, how are the interviews going? They still haven't happened yet, so they at least have some dates now. And yeah, I hope it helps, King. Any tips for a fresh grad regarding coding interviews? I think they're the same tips as for really any level of development, which is like have a good framework, practice, and understand the fundamentals. So the framework for me is just this. Like this I suggest for literally any interview at any level of pretty much any domain is like, are you even on the same page as your interviewer? And maybe it's not a problem, but maybe they're asking you a question and you need to understand the heart of the question. So if they're saying like, what's a time you had difficulty working with somebody? They're not really asking, hey, tell me a story. They're asking like, how'd you overcome that difficulty? So always understand. And then from there, of course, then this differs based on industry or coding or system design or whatever. But yeah, like have a process. And then yeah, make sure you're practicing. And practicing is not just the problems, but also it's mock interviews. And I think mock interviews should be empowering by the end of them because it should either let you know I'm on the right track or I'm not on the right track and here's what the right track is. Whereas real interviews will only let you know that you're on the right track or that you're not on the right track, but it won't tell you what the right track would have been. So you could fail at an interview, not get the job, and they might not give you any feedback. And then it's almost like it was pointless, right? Like you spent all this time. It's not entirely, you still got practice, but you're not guided in the right direction. Okay. And what language is my bread and butter? I've been using JavaScript for everything so far. I can see why I set up all these commands. Yeah. Yeah. I, for like 4.5 years on stream, was streaming just one thing. That was the creation of Botland. So I get the same questions every single day. And we got like 400 commands out of that. And then in the last few months, there's been some different content. So it's a little less command friendly, but still a little bit command friendly. I feel like I'm not advancing significantly. Am I doing something wrong? You could be. It's hard to say. So let's say you did two problems in your entirety of your life, and you're like, I don't feel like I'm advancing significantly. What you're doing wrong in that case is just that's not enough problems. Two problems is not enough to know, to have seen all the different kinds, to have seen patterns between them. If you've done, let's say, 400 problems and you feel like you're not advancing, then maybe what you're doing wrong is expecting to advance significantly. Maybe 400 problems at that point is like, well, you've gotten a lot of information. That's kind of as much as you're going to need to know. So I'd have to know a little bit more to help you out. Hey, Crows. Looks like we can't subscribe. Job Hunt Link says they won't answer your support. Oh, yeah. Sorry. They got back to me. Thank you, MLS. Yeah. I'll go update that. Where is that Job Hunt? Here it is. To same end, I disabled subscriptions on Twitch on July 24th. Why did it just scroll down? What happened? Did I type 24 somewhere else in the top? No. Also, that was the no subs thing. Okay. Thank you, MLS. Okay, let's get back to questions. Let me just finish these off. Yeah, I've heard about Pramp. I haven't used it yet. How many LeetCode problems am I? Like 150 something, I think. Any tips for how to handle single line analysis in tickets? Mac, you'll have to be a little more specific. I'm not totally sure I get what you're saying. One thing I picked up on each one is they never give a good answer to why, when, where you scale. Sometimes it's not even the app that needs to scale, it's more decoupling or architecture. Yeah. I'll write this down. Important takeaways. There are a ton. So it's going to be kind of hard to talk about all those. I think the closest I have is kind of there, but that's not entirely what you're asking about. Okay, so let's move on to the next one. The next one, where were we? Yeah, so I did not get this one. And what we had to do is realize how to split up the like NLR and LRN into groups that were the same. And then once we had those, we just keep doing that. Yeah. Okay, minimum cost tree from leaf values. Another tree problem. Single line analysis tickets. If you keep on getting tickets that only contain minimal information, how do you guide people on giving enough information? Okay, let me copy this. I'll answer this, and then I'll do the problem that I have set out. If you keep on getting tickets that only contain minimal information, how to guide people on giving enough information? So, if I'm interpreting this correctly, this kind of reminds me of like GitHub issues and how they have a, what do they call it? Like a placeholder text almost, where they say something like, you know, I don't know what this looks like exactly, but it's something like, describe your issue here, and then they'll say something like, include what went wrong, screenshots, etc. So just guiding a customer, guiding someone filing information, I think you need to give them information somehow. And there are really only a couple ways you could do this. You could either require it, so you have fields of like what went wrong, and then, you know, minimum of 10 characters or something like that. You require, or you just guide them in that way. You give them prompts of like, hey, what went wrong? Or can you describe this? Or what were you doing? And then the final thing is you could try to auto collect that information sometimes. So let's say they run into an error on your website. Maybe you dump all of the memory state into, I don't know, some error reporting tool like Sentry or something. And then you just look at it yourself. So that's kind of what I think, and I'll probably see your responses after I take a look at this question. So I'm currently not reading chat. Let me set this up. So given an array of positive integers, consider all binary trees such that each node has either 0 or 2 children. The values of array correspond to the values of each leaf in an in-order traversal of the tree. The value of each non-leaf node is equal to the product of the largest leaf value in its left and right subtree, respectively. Oh, we looked at this one, and I don't think I did this one last time, or not correctly at least. So let's see if I can do it correctly this time. So what is this one called? Minimum cost tree. Yeah. So I apparently have this one, and I have no code written for it. Yeah, I did. I don't know if it's worth trying this again. Like, ideally, I would remember, hey, what did I mess up? And every time I don't remember, then I just look it up and I try to remember for next time. But let's test it. Let's see if we can do this time. So let's write down the constraints. So all nodes have 0 or 2 children. The values in the array are values for leaf nodes. And values of non-leaf nodes are the products of the largest leaf values in left and right subtrees. It's not are the products. Well, yeah, I guess so. Return the smallest possible sum of the values of each non-leaf node. Yeah, so this is really tough. And I remember this stumping me last time, and I don't know if I'll make any more progress this time. Almost to the point where I don't think it's worth doing this problem. But let's try again. This is where I was saying earlier, like how do you know what you learned from last time? Like I know for sure I looked at this. I know for sure we looked at the answer, and yet I don't remember any of that. So now chances are I'm going to go through exactly the same wrong steps I went through the first time. And this is what kind of bugs me about this is like I should definitely remember, but if I don't, it's just I just keep looking at this again and again and again until I finally just I know it. So yeah, let's do the wrong steps again, and then let's figure out what I did wrong and correct it for next time, and hopefully next time I remember it. So there are two trees from this one, and I wonder if we can know. Like one of the things I think about here is we could form all of the possible trees, like form all possible trees from the input, figure out which one has the smallest possible sum of non-leaf nodes. But I'm not sure I know how to do this step. How do we form all possible trees? Well, I guess a dependent question here is how do we form one tree? And yeah, how do we form one tree? We know what depth we need and how many values we have. So it's always going to be log 2 of num nodes. And it's going to be the ceiling of that. So here we have 3 nodes. So log base 2, the ceiling of that is going to be 2. I guess we say plus 1 here. And then we have a number of combinations equal to the max depth minus this, I think, or 2 to the power of that. So we have so number of combinations is going to be 2 to the max depth minus num nodes. So here our max depth is going to be 3. Oh wait, no. Do we say this is depth 0? Maybe we say that's depth 0. Okay, so our max depth is going to be 2. So 2 squared is 4, and we have 3 nodes. Wait, I said this wrong. This minus this plus 1. Yeah. Because if we'd filled up all the nodes, then we'd have 1 combination. Okay, but this still actually does not help because I still don't know how we'd form one of these trees. Yeah, and this is what I ran into as an issue. Well, this is probably what I ran into. Like I said, I don't even remember what we did for that. Yeah, so the goal right now is just we construct a tree from this and don't even worry about non-leaf nodes yet. So I know there's a constraint of non-leaf nodes where we're supposed to figure out the products, but let's just ignore that. And I can't figure that out just yet. We know what the max depth is, so I guess we could slot in nodes until we get to a depth that would allow this to work. Then we figure out how many nodes are supposed to go in each location. but that doesn't seem like a good idea. Yeah, I think I should look at the answer to this one too. I think this is another one where I'm headed down the wrong path and I know it. So yeah, let's look at one of these. What a shame. Okay, let me try to I think this is another one of those things where I should just keep doing this problem over and over and over and over until I finally understand what I'm supposed to do. Because maybe in this we don't even form the tree. Well, what? Build a node in the tree. We compared two numbers A and B. Okay, I'm going to look at someone else's summary that they have. Let's look at this, I guess. Okay, so what do we have here? Array.length, array.length. Max. I think I want to look at just an explanation. Similar to trapping the rainwater problem in the largest rectangle under histogram. Use a stack to keep a decreasing order by adding smaller values while there's a bigger value. Maybe this is why I don't remember anything for any of this. These explanations are not the easiest to understand. Yeah, maybe I should just read through all of Lee's answer here. When we build a node in the tree, we compared two numbers. Smaller one is removed and we won't use it anymore. Bigger one actually stays. Given an array, choose two neighbors. Remove the smaller one. And the cost is A times B. I don't think I'd Yeah, I don't think I'd get this. Okay, I need to study this problem. Let me read chat and then let's look at this. Take care, Murphy. Thanks again for the course purchase. I didn't end the partnership with Twitch actually. I just turned off my subscriptions. And I don't know if someone linked this to you, but I've got the no subs command for that. You think that building a big project is gonna teach you more than solving all these small and niche problems? Yes, I do. 100%. I I don't I don't think the interview process at big companies is a good process. I don't know what it could be replaced with exactly, but I don't think it's great. So I don't really approve of this process, but I have to do it if I want a job at one of those companies. I feel like example one doesn't meet the condition in the third bullet point. Example one equal to the product of the largest leaf and its left and right subtree. So left and right subtree here, 12, 6 times 4, that's correct. And then 24, 6 times 4, yep. And 8 is 2 times 4. Yeah. Remember, it's only of the leaf nodes. So if you look at a non-leaf, the only products you can consider are 6 and 4 and 2 and 4. And 6 and 4 are going to produce a bigger one. So then if you look at 12, the only leaves you have are 6 and 2, so it has to be 12. Whereas this one, you look at either 6 and 2 again, or you look at 6 and 4. Yeah. Yeah, by the way, Kaylee, please do try to be careful about segmenting. Okay, so let's keep looking at this. I want to understand this. Yeah. Because like I said, I've already passed this problem up once, now twice. All right, when we build a node in the tree, we compare the two numbers A and B. The smaller one is removed and we won't use it anymore. The bigger one actually stays. The problem can be translated as the following. Given an array, choose two neighbors in the array. We can remove the smaller one, and the cost is A times B. What's the minimum cost to remove the whole array? Till only one is left. A has to be removed by a bigger number. We want to minimize this cost. We want to minimize B. B has two candidates, the first bigger number on the left and the first bigger number on the right. I don't think I'd get this. I think here's how I'd even need to go about this in order to get this solution. I need to test this out with a lot of different inputs, draw out a bunch of trees, and see that pattern for myself. And I think drawing out all those trees would probably like just take up the entire time. So there's always kind of a question in the back of my mind, which is, what if I got this problem during an interview? And if I got this one specifically, let's say the interview was half an hour from now, and I just looked at the answer to this, right? I still don't think I'd produce this. Like, I'm pretty sure I would end up just saying like, okay, this is beyond me right now. And I don't think that's okay, but I think there's always going to be a problem where that happens, and ideally it's just a problem you've never seen before, because all the problems you've seen, again, in an ideal situation, you'd know how you're supposed to solve them. But yeah, I don't know what to do for this. Are you allowed to set a parent member? Yeah, you could. Yeah. Well, I don't know. Is this one of those ones where I should just skip it and say I just want to understand this, and if I got this in an interview, be like, oh, that was that problem, and then talk about how it's not a DP. I think it's best. I think this is just one of those ones where I just say like it's not worth it. So we'll move on. And I think that's what I'm gonna have to do. And this is what I was trying to say with my where is it? My go easy on yourself. It's very natural for me to say I didn't get this, so something's wrong. But like I probably just won't get this. That's okay. So I shall move on. So what's the next problem we should do? Apply discount every n orders. When the person doing the interview leads you with hints, and yeah, interviews give hints. Yeah, they probably would. But I think that if an interviewer gives you enough hints, that they'd probably be like, well, they only got the answer because of my hints at this point. So yeah, I'll have to see what happens in an actual interview. I think that's why in an interview, it's don't give up and hope that your interviewer helps you enough. But in practice problems, like there's got to be a point where you give up, otherwise you might spend 20 hours on one problem. Is the answer available? Yeah, it should be. If you just scroll up in chat by like 6 messages, it should be just click discussions. Yeah, and then just look through any of these. Like there are lots of people's solutions here. You can click any of them and take a look through. Hey, Artie. How many links, or is that not allowed to be known? It's like 4, I think. Okay, so let's edit this as the problem. Let's turn this thing back on. So there's a sale in a supermarket. There will be a discount every N customers. There are some products in the supermarket where the ID of the ith product by only some. There's some products in the supermarket where the ID and the price. What about for the other products? Not that. Oh, maybe this is poorly worded. Maybe this mean there are products or products in the supermarket are identified by this and the price is this. Yeah, that's probably what they mean. Okay. System will count the number of customers, and when the nth customer arrives, he or she will have a discount on the bill. The cost is X. The new cost is X minus discount times X divided by 100. Oh, okay. Then the system will start counting customers again. Customer orders a certain amount of each product. Okay, I'm not doing this. This is too much to read. Let's just move on to another one. Okay, maximum difference between node and ancestor. So given the root of a binary tree, find the maximum value v for which there exist different nodes a and b, where v is the absolute value of the difference of them, and a is an ancestor of b. Okay, so a node is an ancestor if any child of a is equal to b, or any child of a is an ancestor of b. Sounds good? So it makes sense? So what am I supposed to find? The maximum v for which there exist different nodes a and b. So what are we looking at here? Output is 7. Various ancestor node differences. Hey, Lumi, thank you for the raid. Hey, whoop. That I can't click in chat. There we go. I hope you're streaming well. I'm currently not reading chat right now, but I do see those messages because I see something pop up in OBS out of the corner of my eye, and I'm like, I should look over there. So thank you for the raid. For anyone new, do check out the today command. We're just doing LeetCode problems. So let's see, what do we have here? A minus 3 is 5. A minus 1 is 7. Among all possible differences, maximum value of 7 is obtained by a minus 1. Okay, so how can we solve this problem? We want the maximum difference between a node and its ancestor, and any of its ancestors, which is pretty much saying we want the same thing with any of its descendants. And so what if we could consider splitting this tree up so that we found the maximum difference? Well, I guess let's think, how do we maximize the difference? We want the farthest value. But can we know anything based on the difference in a subtree? Because 8 minus 1 is what we want here. So if we were to, can we copy this? If we were to sum up, like let's say we just looked at this tree. This is going to be 3, this is going to be 2. This is going to be 1, this is going to be 2. So that at any given node, at any given edge, we can look at these things. So I don't think this helps us at all because I don't think this helps us at all. Unless we kept track of it as minuses and pluses, then maybe it would. So minus, minus, plus, minus. Oh, this is a binary search tree. I don't know if it's always a binary search tree. Okay. Did they say that? No, they just said binary tree. So it's not guaranteed to be in this order. Which, even if it were, I don't know how much it matters. But okay, so in order to maximize this value, again, we have all these edges, and this could lead to like a negative 100. Or I don't know, let's say this one led to a negative 100 actually. Well, I guess it'd be negative 107 if I wanted to be negative 100. Yeah. In which case this would change the answer. But what I'm kind of getting at here is that at any given point we could figure out what's the biggest difference in a subtree. I had to think of how this will work for, let's say we had like 18 and then 2. So this is plus 10 and this is minus 16. But the difference between here and here is only minus 6. Yeah, and we're not guaranteed to use the root as part of our answer anyway. Because I don't know how much we can. So here's what I'm trying to figure out. Hunches, either we like test everything or figure out how we can use the result of a subtree to solve for the bigger tree. So if we have any tree A, B, and C, this is really easy because it's either, answer is always either A minus B or A minus C. And granted, it's the absolute value. I'm not going to write that out. So, can we use that for the parent level? Or maybe there's something else we carry up to different levels, like the minimum and maximum of that tree. Yeah, I guess if we're trying to maximize the difference, that's what's going to do it. Maybe we only care about the min and max of each subtree. Yeah, I think that's it. And then we figure out, I don't know what we do after that. But so let's go annotate this thing again, paste this in. So if we were to just look at this, we get 1, 6. If we just look at this, we get 4, 7. If we look at the whole thing, we get 1, 7. And then we find out which sum that gives us. Still haven't actually come up with an algorithm here. So given a node, determine the minimum and maximum of all children, all descendants. Which it'd be nice if I spelled things correctly. So then we also compute the, we want to maximize the difference. Yeah, also compute the maximum difference from those values. And then we could just do this recursively, I guess. But aren't we going to end up comparing every single node? I'm not sure. Guess we kind of have to, right? So given a tree with no children, its min and max are undefined. Tree with no children has a min and max of undefined. Tree with no, actually it's not that. I don't know. I want to write out a little bit of code here. I think it'll just help me think about this. This is where my anxiety starts to go through the roof because I keep thinking, man, I've done these problems a ton. I shouldn't give into that. All right, let's just keep looking at this. So we want to find the minimum and maximum at any given, right? So function like compute min max of a particular node, and min so far equals infinity, and max so far equals negative infinity. All right, so if the node is null, then return min so far, max so far. If the node is not null, then we want to return, we want to get the min and max of the other ones. Min so far, min left, max so far, max left. This won't work if we never compare the values that we got, right? Which I never did. This is why I wanted to figure out what I'm doing. Oh man. All right, so what am I doing here? Let's say we have, what's our base case that we have? So like 8, 3, and 10. And also let's consider something of 8. If we have 8, we consider our min and our max to be 8, except that it can't be the same value. Are they distinct? They do not say that they're distinct. No. So then we can't rely on that. So then the max of just this, we'd have to pass in, yeah, it'd have to be negative infinity, infinity. Okay, whereas the max of this is that we compare the left value with our current min that we have so far. Okay, let's do that, I guess. If no dot, no, that doesn't make any sense either, right? I'll write it out. If this is not equal to null and no dot left dot val is less than min so far. Min so far, no dot left. And then this would be the max so far. And we do the same thing with the right. And then there was something else I wanted to do, right? Then we compute the min and max of the left and the right. I think I'm still messing this up. I don't think I've considered the base case correctly. 8, 3, 10. So we have a minimum so far of infinity. So we'll set this as the min and the max. And then we'll set this as the max. And then I want to call that recursively. But I actually want to store at each, I want to store each node the min and max. No, I'm not sure. I think I should skip this too now. I think I've spent long enough. I wonder if this means I should just try out more tree problems or something else. I don't know. Let me read chat. Do I have a LinkedIn? I have a LinkedIn. I really want to deactivate it, but I'll do that after the job search, I think. In fact, I don't know why I didn't think of that sooner. Where is this? Here it is. Yeah. You think those LeetCode and other code challenges are a good indicator of workplace performance? No, I don't. Okay, so let me read through what the solution is. Pass the minimum and maximum values to the children. At the leaf node, you return max minus min through the path from the root to the leaf. Yeah, all right, I gotta take a break. I think if I'm not getting 3 problems in a row, it's probably a sign I should stop. Well, I might come back later because I still think I need a lot more practice. But this started going pretty poorly. So thank you guys for watching. I'll see you later.